Okay. Yep. So hope everyone can hear me. So yeah. So welcome to another installment of the KL mini hack. Today we'll be having WenKang, which is who is a software developer from Nethermind and also a very active member of ETH presenting the topic Cairo, a quick look at the provable programming language. So without further ado, let's get started.
Hi, nice to have you all here. Thanks for coming. I'm WenKang. Thanks, Calvin, for sharing about me. So yeah, here today we are here to look at Cairo, provable programming language. So what exactly is Cairo? So to add some context, Cairo is a Turing complete programming language for writing provable ZK start programs. It allows developers to very easily build efficient and scalable L2 dApps with L1's security with exponentially greater throughput. So what does this mean, right? It's a bunch of mumbo jumbo. So well, essentially, Cairo is it's similar to Solidity in the sense that it's a smart contract language in a sense used by Starknet and Starknet as well for the development of smart contract and the apps. However, instead of being a very domain-specific language, it's very much a general purpose Turing complete language, meaning that it can do a lot more. It's not constrained within what is possible only in the EVM in a sense. So it's used by Starknet, which powers DYDX, decentralized exchange, radio, and also immutable. Some of them might be very familiar to you, but you can look that up. They are quite interesting use cases that Starknet and Cairo is being used for, and it's also a smart contract language used by Starknet. Okay, so before we continue, let's have a quick refresher. Some of you might have already seen this yesterday on the Starknet talk. So essentially, this is what Starknet architecture is like underlying. So as most of us know, Starknet is a L2, and as we can see here, a user account, which is a smart contract, will usually have a create transaction and which will be sent to a sequencer. And the sequencer itself is Cairo OS or Cairo VM, which can run a Cairo program, which will process your transaction coming in, and after processing it, it will send the, so to say, execution trace to a prover. We call it a sharp prover, and this prover will then generate a proof and send this proof to a smart contract on layer 1, basically back to Ethereum, and this will then be committed essentially to layer 1 and update the state essentially. And the proof and the state difference will also be sent to a full node. So this is like a very general look on how a Starknet architecture is like. And in this case, what we'll be focusing on is mainly on, so to say, the Cairo OS and the language that essentially this OS, this operating system, this computer, this VM speaks. This is a simpler diagram of it. The Cairo code essentially gets processed by a prover, which generates a proof and then sends to a verifier. And the verifier will then commit all this to a layer 1, essentially. Okay, so now you might have the question of, why do we need a prover language, right? What's there to prove about, right? Language should just be a language. We all are familiar. I think most of you here are familiar with TypeScript, perhaps some Python, perhaps C++, whatever, right? There's a lot of language out there, and why not just be like that? Why make it provable, right? Why don't we just have a language like Cairo for like just be like Solidity, right? Like Viper and all that, right? There's a lot of different smart contract language, but why do we want to use Cairo? Why is provable a desirable trait in a language? Well, it's essentially so that we get to retain the computational integrity of an execution program in the Cairo VM or like on Starknet. So By computational integrity, what does it mean? Well, so someone called Lewis a long time ago said that integrity basically means doing the right thing even when no one's watching. So computational integrity essentially refers to the same thing, in that it means that even when no one is actively trying to look at it, like look at the program, you are actually computing the right thing. You are running the correct function, you're running the correct routine, and you're not doing anything else. There's a lot of ways of ensuring computational integrity, just to give some example. So as we can see here, there's different type of ways of doing it. Reputation, delegated accountability, these banks, right? We trust that banks are doing the right thing, although we can't really see what they're doing in the background. Naive replay, Bitcoin, which basically trusts that you are kind of doing the right thing by doing replays of your transactions. Trusted execution environments, this usually refers to a machine or a chipset that you trust to run things correctly. Fraud proofs, which are a blockchain use case, and I mean it's also a real life use case, but here we refer to optimistic rollups, where something like Optimism, something like Arbitrum, they are optimistic rollups, and they utilize fraud proofs to ensure the integrity. So and finally cryptographic proofs, so something like ZK Stacks or even ZK Snarks. So here, since we are talking about Starknet, which uses the ZK zero knowledge stack proof system, we talk about ZK Stacks, but there are also other blockchains that uses different kind of proof system, something like Snark, ZK Snark. These are very interesting topics that if you would love to look at, feel free to look it up. They are quite available as well. Maybe Kevin can add some links on that here in the chat as well later. But yeah, so these are multiple ways of ensuring computational integrity. So essentially what this allows in the very long run is that it allows Starknet, which runs on Cairo, to very easily upscale like from what we have right now. So as most of us know, as of now, to know that a program is run correctly, you would basically have to give that program to another person who would then run it, and then you can then verify that yeah, it's run correctly. So as a live reference, right, you can see that if I want to prove to another person that some program has run successfully and produced a hello world as an output, I basically have to give the program to that person, and that person will then run it on their own machine. And if it gets hello world, right, you know that it's correct, right? You might run a few more times just to be in case. But yeah, that's the idea. With computational integrity, with something like a Cairo, which can just generate a proof of that, you essentially can achieve something like the right diagram, where you can run a program, right, and generate a proof of that execution. So you can execute a program, you can run a program, and you can generate like a trace of the program, which can then be made into a proof. And now with this proof, without actually showing what the entire program is, or even walking through what the entire program line by line, you can just pass this proof over to another person, and that person, because of cryptography, can just take this proof and pass it to a verifier, which can verify if the proof is right or wrong. So I mean, this two diagram looks quite similar. One might ask, no, it looks the same, but like it looks like just the first one with extra steps. Well, the part that makes it different is this. Imagine a decentralized network where you have to somehow prove that you have done some transaction. And this becomes and then what we show here becomes very obvious. So in this scenario, if we rerun each transaction across all the compute, or like everyone, so everybody have to somehow verify this, they'll have to run it, they have to check it, they have to check if it's the correct. output. If let's say I send someone about 5 ETH. If the 5 ETH is sent, if that change has been made, and if it's been made, then it's a valid transaction, things like that. So if we use something like a ZK Stark, or in this, something in this kind of cryptography system, what we can achieve is that now everyone involved in this network can essentially just verify the proof, which is a lot less power hungry than perhaps a program may be. Because right now, if you want to try to run something very computational heavy, very complex on the blockchain, it will cost you a ton of gas. You'll get charged for that, because you have to go through every single step, run it. The EVM has to run it. EVM has to check that this is correct, that is correct, and all of this basically costs computational power. And in a blockchain, it basically costs you gas, right? With something like a cryptographic proof, like ZK Stark or ZK Snark, even, you essentially can just prove that yes, I have done this computation, right? And without re-executing the entire thing, everyone just only needs to verify that proof, which most of the time would be a lot cheaper than re-executing a program, perhaps. And this essentially allows Starknet and Starkware, or like StarkX, to have very low gas fee while being able to perform very complex operations, right? And that's what Cairo is made for, in a sense. Cairo is a language that's made to allow you to write programs that are provable. And with this, you essentially can then prove that you have done something, and everyone can verify that you've done something correctly without needing to re-execute again and again. So yeah, let's move on. So essentially, yeah, this is what I've just described. It's a diagram of how it essentially is. So your program will be passed to approval, which will generate a proof, and then essentially this proves that you are moving, like proves that you are moving from the old state to a new state, and this now will get verified by everyone, every participant in the network. And this is a lot cheaper than just rerunning everything again and again. So, right, a lot you will say, like, yeah, I know until this point, yeah, it's cool and all, but I can only run in a blockchain. Well, with a project called, there's actually recently a project called Shenlong, which is a Cairo to LLVM compiler. So this essentially allows you to run your Cairo program offline. And the implication of this is that now you do not need to only use Cairo for like blockchain stuff. You can essentially potentially use it for a lot of things. It's not only a blockchain constrained technology. It's a very generic technology. And given that it's a Turing complete language and a general language, like it's not limited to smart contract anyways, what you can do with this, I mean, you can only imagine, but you can do a lot with what you have here. Okay, sorry. So just like going a bit deeper into Shenlong. So Shenlong is essentially Cairo LLVM, as I've mentioned. And LLVM is a language backend that allows you to compile to usually C code, C-based code. It's a C-based backend. So yeah, so with this, essentially you can write Cairo code, and you can now run on most of the machine, if not all of the machine that we currently use, because LLVM is essentially the backend that converts your code into a machine code, to put it very simply. Okay, yeah, I've said a lot. I've talked about Cairo a lot. So how does it look like? What it might look like. So let me just show you a demo. So allow me to just pull this over. Okay. So for those that are familiar with Rust, this will look very familiar to you. This is a very simple program, I would say. So to run a Cairo program, essentially you can just use Cairo run. But here, this is actually their repo. I mean, I've cloned down their code core repo. It's actually powered by Rust underlying it as well, but it's the backend is written in Rust, but this is essentially what it looks like. So allow me to just okay. So let's put something simple. So just to type this kind of thing in. Give me a second. So I mean, it also needs a main function usually. Let me just try to return like what 0. Just return 0.
Chen, sorry, can you zoom in like one or
Okay,
twice?
sure.
Yeah, sorry about that.
No problem. Give me a second. I have forgotten how to zoom actually. Yep. I think does this work?
Okay, I think it's good now. Thanks.
Okay, thank you. Thanks for the reminder. So let's just try to return a 0 and let's try running this, right? No, who knows, maybe this can't run. But yeah, as we try to run, can't return 0. Yeah, because it's telling me that I'm not essentially telling it what to return, right? It's expecting like essentially a void. Now let's try running this again. Yeah, it returns 0 as shown here. So some might see felt and be like, well, what the hell is felt? This is clearly an int. What are you talking about? So here felt actually refers to field elements. It's a very specific, I would say it's quite specific to Cairo in a sense. So felt refers to field elements. It's essentially 252 bytes of integer in this sense. Why do we use felt? Well, there's specific properties that which I wouldn't go very deep into, that Cairo requires to function essentially. And felt is a very major, it's like a primitive for Cairo. There's also other primitives that comes later, but essentially most of the fields, most of the data, most of the things in Cairo is a felt, so to say, a field element. That includes this. Yeah, 0 is a felt. So second, okay. So sorry. Thank you. Okay, we're back. So right now, let's try something a bit more complex, right? Let's just do addition, right? Why not? 1 plus 2. I mean, this is very simple stuff. It works. It's very hard to not work. It's just 1 plus 2. So yeah, 3, this and that. So that's fun and all. Let's try doing some logic, I guess. I mean, most of you would already know things like variable declaration. So yeah, you can declare a variable, return the variable. This will work. I'm going to run it for just to show. There's also some very nice Rust feature that's being added into this. So let's say pattern matching, right? It's something that's quite nice to use, as it allows you to do things like this. It's breaking for a bit. Let's try running this. Might break. Does it work? It works. Yeah, it's 5, 0. So let's change this to 5. I think it's not really working that well, the linting right now. But it should run as expected. It should return 3. Oh no, it's matching to non-zero value is not supported. Let's try this then. Return A if it's not 0. Let's try this. Yep, returns 5 as expected. So this is something that's pretty nice to have. There's also enums in this language and all, but let's just try something that I have here. So it's okay, nice. So this is basically Fibonacci. As most of you may know, Fibonacci basically is just something like this. The sequence looks something like this, and we can calculate it up to, I mean, let's try 5, which in this case would be 1, 2, 3, 4, 5. Here, I think. 1, this 2, this 3, this 4, 5. So let's try this. This is a function. Also will look very similar, very familiar with everyone that uses Rust in the first place. So yeah, it returns 5 as expected. I mean, nothing special here. I'm not going to demonstrate sending this to the sharp prover to generate a proof. But you can potentially send this to a sharp prover to generate a proof for what you are going to do. And you will basically generate a proof that, yeah, you have run this program in a certain way. There's a lot more things like structs and all, but yeah, you see, you can see it looks something like this. If you want to go into it, there's also, I believe, just take a look. It has something like a struct. It looks like this. This is, you can create your own structure. This is its own type, and you can essentially create something like this. And this is very much runnable as well. I mean, I can try running this. Just adding a min function, and then just return the fib result as well. Return the result fib 1, 0, 1. Let's do it 100. Let's try running this. Drop. Yep, it returns the result value, which is the 100th Fibonacci sequence, and also returns me, I believe this is the index. Yeah, 100. Yeah, which is correct. So yeah, something like this. There's a lot more to this. I'm just going to show very simple stuff here because it's not really a workshop, but do look forward for a workshop that's going to come later. By later, I mean like in the future. Yeah. So yeah, that's like a very, very short and simple demo. I'm going to show, so this is not in the demo, but I'm going to show you how a ERC20 contract looks like in here. So it essentially looks like this. You use this annotation to mark that, yeah, this is a contract, and everything else, it's quite, I would say if you're familiar with Solidity, this will look quite familiar to you. One thing that might be a bit unfamiliar with is probably the function. So as you can see, it's declared like a function instead of like event transfer. Not sure if they're going to change the keyword later, but yeah. And also you might look at, I mean, this is all very familiar, I think, to most Solidity users. The constructor, well, you know what constructor is, essentially all this is written in. So as you can see, you don't actually directly assign your felt in a struct. You actually use something like a write function to write the value into your storage. This is a bit different from like just directly assigning, but yeah, this is essentially what it does. So there's also assert, which does the checking. Transfer, this emits a function. This is essentially a what's it called, a event that you're emitting. Just directly put it in and you will emit an event. So yeah, most of this would probably look very, very familiar to you. Yeah, approval function, which basically just called approve helper, which is here, basically just checks, and you know, if it works, I will just write the allowance, set your allowance to a certain amount, and emit an event. Yeah, this is how an ERC20 contract in Solidity will look like in a Cairo, in the Cairo syntax. Okay, so one, like as I said, right, most of you might already be familiar with Solidity. So what if you want to start with Cairo, but you know, it seems like quite a hassle to relearn the language, quite a hassle to start doing this, right? It might look cool, it might do cool things, but you know, how do I start? Well, a very good, I would say something that's a good news to you might be WAP, right? It's a transpiler. It's a transpiler that allows you to transpile your Solidity code, what you currently have, to essentially Cairo code. So, of course, a lot of times, this is not perfect, but it does help you start off your language learning journey a lot easier. At least for me, most of the Cairo syntax are quite friendly, and with right now what we have for Cairo 1, it's very much getting better. But still, right, it helps to have a transpiler. And this currently is actually already used by Starknet, which is a company responsible for Starknet as well, to basically transpile the entire Uniswap V3 contract into Cairo with some modification. So you can check out the contract. You can check out the code at github.com/nethermind/if/uniswap. It's essentially Uniswap completely written in Cairo. This is also very, I mean, it's quite friendly to use as well. So it basically looks like this, right? It compiles your contract and then it will transform it into here, what we have here, right? These are all essentially transpiled from here. You can see some weird artifacts like get data underscore this, but these are completely working and it's deployable from the get-go. I'm gonna also do a short demo on WAP, so let me just get that up. Okay. Okay, so let's. Okay, so one caveat right now. I'll talk about the caveat later. Okay, so let's try compiling some contract. Since we were talking about ERC20 anyways, so this is a ERC20 Solidity contract. You can just change this, it's fine. But as you can see, you have all the functions, this and that. It's a very simple contract. So let's try to compile this. So to install WAP, it's basically very simple. You just have to install it. It's this command. Just install your WAP in, and it should be available as a global executable. So let me just transpile like ERC20. This. Okay. Let's transpile this. So after I transpile, it should be available at the output file. Here, you get the ABI and also the Cairo code. So I'm going to explain why this Cairo code looks slightly different from the one I've been showing just now later. But essentially, this is an older version of Cairo. Right now, they are actually doing a migration from this older version of Cairo to a newer version of Cairo. As you can see, most of the things is actually here. The write functions here to write it into storage. Let me just look for like, yeah, this is the transfer function. It's very sparse right now. Total supply, it accepts a uint, and then you will set total supply, get total supply. Decimals as well, returns the decimal you have, which is 18, is standard in the original contract here. Let me just go and take out the original contract to compare. Here, so balance off, right? It actually does the same thing, but as you can see, they have specific syntax for this. So this one basically checks, gets the account. This account is essentially the input from here, and you read this, convert into uint 256 because felt is actually 252. You have uint 256 is not like it cannot fit 256 bytes into a felt, so you actually have to explicitly convert it into another type. And yeah, you read it and you essentially get the balance. That's the same thing. Mint, let's look for mint. Yeah. Balance 2 plus amount, slightly longer here, but it does the same thing. These are all conversions and this is reading. So it's basically doing the check if your amount is good enough, if the address is correct, if the amount is correct, and then you will just do some assigning and write it to storage. Yeah. This return one, doesn't actually, it's not, so to say, if you look at, yeah, it essentially returns true, right? In this case, it actually treats it as a one. Yeah, it does the same thing. Yeah, so that's essentially how WAP works. You can transfer a lot more things. So you can look at some of the examples that actually give you. You can actually get this all from the GitHub repo, WAP from WAP. But let me just take, yeah, this basically just checks for fallback function. It's compilable, literal operation. That's very much contract here to test. But this is one of the things that essentially they use to test if WAP is working as expected. We can try to compile this as well. Oh, I use local variable. Let me just do. Oh, sorry. Let's remove this since it's unused. File, and it should be available down here as an output. So again, Cairo. This is a bit more complicated. It actually does computation on, I believe this is, I think, the implementation of an array in Cairo. But let's just look at the storage. Length. Yep. Essentially, it reads the length and get an amount, and it returns it. It's quite readable actually, but it's not like this is very distracting. But yeah, it's essentially quite readable. This is also seen in the new Cairo version, but it's just in different syntax, slightly different syntax. So yeah, that's WAP essentially. So, well, as someone who started this, so as someone who has started venturing into the ecosystem, you might start looking for projects and things to, I would say, explore. There's actually a lot that's already there. It's very quiet for those not in the Starknet community, but there's actually a lot going on. And once you go in, you realize that people are doing a lot of amazing things. So these are everything here. So you can scan the QR for the documentation. It's currently still in Cairo, older version of Cairo. So regarding the Cairo version, one thing is that there's currently a very huge migration going on from Cairo 0.10 to Cairo 1. What I'm showing you is Cairo 1, and it's actually already functioning as I've shown just now. But a lot of what is on Starknet chain today is Cairo 0.10. But the next version of Starknet, which will come, I think, very soon, so Starknet 0.11, Starknet Cairo 1.0 will be supported from that version, starting from that version. So I would say this is like a very good opportunity to start exploring this language. It really does help. I mean, it really does allow you to like be aware of a lot of things happening as well. You're basically starting to use like a language that just came out, right? It's basically like that. So yeah, there's a lot going on. So I'm just going to go through all the GitHubs here. So language core, this is the Cairo language core. It's written in Rust. The backend is written in Rust, but that is currently in heavy development. Like there's been a case where I put the code in for myself to start working on it. I tried to contribute to it, and I think about half an hour after, there's like 40 plus commit already going into their main branch. So yeah, it's in very active development, which is a good sign. But yeah, that's accepting a lot of contributions. So go and take a look. If you're interested in programming languages, it's gonna be very fun for you. For tooling, there's a lot of tooling. Like WAP is one of the tooling. Protostar, and here is actually something similar to Hardhat in a sense. It's something to allow you to write Cairo contracts. This essentially allows you to very, very easily create your contract, deploy your contract using just proto start, deploy. Yeah, that's something that's currently ongoing. Horus Checker, this is by Nethermind. This is a SMT checker. It's related to, it's a bit technical. This is related to formal verification, which is like a security, a way of basically auditing your contract that's currently being worked on. The Scarp is essentially like Cargo in the sense that it's a package manager for the Cairo ecosystem as well. So yeah, those are all the tooling happening. There's also a lot of application going on. There's Starknet multisig, which is just a multisig wallet written in Cairo. There's Cairo Graphs, which is a library for drawing graphs in Cairo. So yeah, things are coming by. There's Kakarot, which is a ZK EVM implementation, completely written in Cairo, deployed on Starknet. So yeah, essentially that's a EVM inside Cairo VM as well. So that's quite fun if you think about it. You can deploy contracts to this VM and it will run. So yeah, that's fun. Like as I said, it's a growing ecosystem. There's a lot still in the works, but that's also why it's very exciting to look into this right now, to start looking at this, to start playing with this. Most of the use case right now is still focused on the L2 Starknet, the L2 chain Starknet itself. But as I've shown, before, it has a lot of potential as a provable language. It allows you to do a lot of things, it gives you some flexibility in how you can use it other than just being a DSL. Right? I think that's why it makes it so exciting to, or at least me. So yeah, that's essentially it for me. So yeah, that's Cairo. I hope you enjoy the talk. Well, I think I can start accepting any questions, if any.
Feel free to unmute and ask if you don't want to type everything out. Anyone has any questions? Yeah. Okay. Maybe I'll have a question. Chen. So personally, so you mentioned quite a bit of tooling and application. Which one of these is like your favorite so far? Perhaps you can talk a bit about that.
Yeah, sure.
In terms of Cairo usage. Yep.
Okay. Personally, for tooling wise, I'm very much a tooling guy, I would say. I personally really like WAP. It's what when I first started using Cairo, it's what helped me quite a lot in understanding how Solidity translate to the Cairo language. And it's also interesting to me as I'm someone who is very interested in programming languages and how how languages are compiled, how is it processed, things like that. So yeah, for me, WAP is very cool. I think one of the most impressive projects that I think, which is also shown, is Kakarot, which is it's essentially like you are creating a virtual machine inside another. You are creating a virtual machine with this language, right? It's a new language, and you can really write a virtual machine in it. So that's very impressive what they've done, right? It's called Cyanogen Labs, but yeah, it's very impressive what they've done with Cairo and what they have achieved with Kakarot. I think I see a question.
Yep.
What are the main difference between Cairo 0.10 and Cairo 1, I believe?
1.0, yeah.
Okay, so there's a few different. So Cairo 0.10 is what currently is live right now. If you go look at a lot of Cairo documentation and a lot of Cairo code, it's currently written in Cairo 0.10. It's quite a low-level language in the sense that you have to. Okay. Let me just show. I think showing is easier. Let me just show the code. If you look at a Cairo, this is Cairo 0.10. So what it essentially have is you can see all this like syscall pointer, Pearson pointer, range check pointer. These are things that the Cairo VM uses to essentially prove that keep track of everything in this machine or in this OS and allow them to create proof and certain operation. So these are very much low level. And for a lot of programmers or for a lot of developers, this is not very intuitive and it creates a lot of overhead for them. So Cairo 1.0 takes away all these things and make the syntax a lot easier to understand, gives you a lot of syntactic sugar to make it look a lot nicer. I mean, if I just give you like a comparison of this two, let me just take it this. You can see this is like a lot more cleaner. What this have here, right? Just return function. You don't need to think about like Fibonacci, not Fibonacci, like all the pointer, Peterson pointer, things like that. You just look at this and it allows you to do a lot of things, and it's very modern syntax as
well. Yeah. There's another question asking if there are any other comparable languages to Cairo in like ZK rollup kind of context.
Yeah. So far from my understanding, okay, so there's actually a few rollups that have their own languages. I mean, rollups actually most rollups either use Solidity. One of them have their own language. I believe. I think ZK Sync does have their own language. I'm not very sure how that's going, but from what I know about that language, from what I know, I don't know a lot, but from what I know, it's not really a Turing complete language. It's more of a DSL. That's my understanding. I might be wrong, right? Don't quote me on this. I see. So Qishan actually helps us. Yeah, the version of Solidity to compile. So yeah, I think there's also Zinc. They have something called Zinc. I'm not very sure about Zinc, but yeah, things like that. And for a lot of ZK rollup, they either just have Solidity compatibility, or they actually, I think most ZK rollup I know does only have Solidity compatibility. But if it's non-ZK rollup, like let's say they are a zero knowledge base chain, something like Mina, for example, or even I think yeah, those usually have their own interface to it, which are also most of the time DSL. For Mina, at least, which I know more about, it's a DSL that allows you to write basically circuit in like their smart contract is essentially a type of circuit, right? But it's written in TypeScript, which is quite friendly as well. But yeah, very little. I would say Cairo is quite unique in that it is it's a Turing complete language that can also be used for smart contract. Yeah, Leo as well. Yeah, Alio. Yeah, she's actually giving out a lot of chain as well. There's a lot of ZK chains that each does different things. They have their own language for it, but I believe, I mean, yeah. Any other questions?
While we wait for more questions to come in, I have another question. If new 0.10.
Sorry, I think you are muted. I can't really hear you. Yeah, sorry.
I have another question. So if I'm coming into Cairo, do I just jump into the newer 1.0 version? There's more Rust-like, or am I missing out if I don't learn or go through some of the older syllabus written in 0.10?
Good question. A very good question. Okay, so right now, there's a lot of similarities between 0.10 and 1.0. That's the only thing that have changed, is that it's a lot friendlier to write. So going through the old materials won't necessarily make you not be able to write the new syntax. But in the community right now, a lot of people are recommending learning the Cairo 1.0 syntax, since it's it's actually quite, I think it's end of this month, they are releasing already a compatible Starknet version that accepts 1.0. So I think starting to learn the 1.0 version would yield a better result than going through the entire thing. But if you're going through the old material, it will still give you an insight of how it might look like, how it might feel like.
Yeah, I'm guessing it'll also give you some appreciation of what the Cairo team has done as well. Yeah.
Yes, definitely.
Yes.
It's a lot better.
Yeah.
Yeah.
Okay. Any more questions from the crowd? Feel free to unmute if you do have any questions. Okay. Seems like that might be it. So yeah, I guess we can sort of wrap it up here. Okay.
So before we end,
yeah.
should Kevin, do you want to talk about the talk that we have tomorrow?
Yeah, I was true. Yes. So yeah. Before I end, we do have another talk tomorrow. Hold on, just get the title. It'll be on scaling Ethereum with rollups and zero knowledge proofs. So this will be presented by Scroll, and it'll be tomorrow at 10 a.m. So before you leave, let me just quickly drop the link here if you haven't signed up yet. So hang on, chat. Here. So I dropped the link. Yeah, so feel free to sign up. So the reason why it's at 10 a.m. is because time differences. But we will definitely be recording this as well and uploading it to the YouTube channel. So stay tuned, everyone. And I think that is it for today. Thanks everyone for joining. I'll just stop the recording.